In this video, we're going to learn about rotations and solids of revolution. So what that means is we're going to look at a two-dimensional shape and we're going to look at how to rotate that and make it become a three-dimensional figure. So what's going to happen is we're going to take a two-dimensional shape and instead of rotating it around a specific point and keeping it in two-dimensional space, we're going to rotate it around a line and it's going to end up becoming a 3D figure. So before I actually do the problems in the notes, I want to show you a couple of things on GeoGebra just so you can visually see what's happening. So if you look at this first example, if I take this triangle here and I want to rotate this about this leg or this side right here, watch what happens. So as I rotate it 360 degrees around that side or around that line, keeping that segment in place, I end up with a cone. So imagine the triangle, it comes off of the paper and then goes back behind it, or it went behind it and then comes in front of it. But that side of the triangle actually now becomes the height of the cone, and the other side of the triangle here becomes the radius of the cone. So let me show you one more. If we start with a rectangle, so if we start with this rectangle, and again, I'm going to lock this side in place here, O1 and O, that's going to stay in place. And what I'm going to do is I'm going to rotate this rectangle around that segment, or around that axis, and now you can see that you're ending up with a cylinder. So again, that side of the rectangle we started with becomes the height of the cylinder, or the distance between those two bases, the perpendicular distance between those two bases, and this other side becomes the radius of the cylinder. So we can do this with any two-dimensional shape. We can rotate it around a line, and we'll see some more examples of this in class. But for the notes here, now that you've visually seen that, let's look at a couple examples and how to actually use volume or use these new shapes or these new 3D figures to find volume. So it says that we start with a right triangle and it's rotated around line L, so it's rotated around this side or around this entire line. And what's going to happen is, imagine this triangle, so this edge here is coming off the paper and going behind it. So the easiest way to kind of sketch this is almost think about reflecting first, because this is going to have to end up down here, so kind of reflect it over that line. But because it went up off the paper, we get that three-dimensional piece, which means you're getting this circular piece, so you end up with a cone. So we end up with a cone. I'm going to go ahead and just kind of redraw it over here as a cone so I can label everything. Notice I turned it sideways because I always like thinking about height as it's up and down. So this is going to be the height, the 4 inches. And then the radius is going to be 3 inches. And when I look at finding the volume, well, now it's just a basic cone problem. So the hardest part is seeing the new figure. So the volume is going to be 1/3 pi r squared times h. And let's leave this as an exact answer. So we're going to, it doesn't say to round, so I'm going to leave it as an exact answer since it doesn't say to round. So we're going to leave it in terms of pi. So it'll be 1/3 pi times the radius squared times the height. So I'm going to enter everything into my calculator. So 1/3 times 3 squared times 4. So I end up with 12. So it'll be 12 pi. And then it's going to be inches cubed, since we were dealing with inches. So there's one example. Let's look at another example here. So now we started with a rectangle. So remember, we're starting with a rectangle. It's getting rotated around line L, and then it does say to find the volume of the cylinder. But keep in mind, how do we know that this becomes a cylinder if it doesn't tell us that? Well, think about this as it comes off the paper and then it goes back behind it. So when I go to sketch it, I'm almost going to reflect this over the line to see where it would match up on the other side of my line. But remember, it's coming up off the paper and it's going behind. So it's rotating 360 degrees. So that's how you're getting those circular pieces here, because it goes up off the paper and then behind the paper. So there's my cylinder. So I have a radius of 5 inches and a height of 2 inches. So let's go ahead and find the volume. Again, this one, let's do an exact answer as well because it doesn't specify. It's always better if it doesn't specify to give an exact answer. If it wants us to round, then that means we'll round. It'll tell you that. But in this situation, it doesn't tell us that. So let's leave it as an exact answer. So volume for our cylinder is pi r squared times the height. So we have pi times the radius squared times the height. So again, I'm going to type in 5 squared or 25 and then times that by 2. So 25 times 2 is going to give me 50. Pi units on here are going to be inches cubed. And that's it. So really, this video is just about being able to recognize a two-dimensional shape becoming a three-dimensional shape by rotating it over or around a line. And then after that, it's just using your basic volume formulas. And like I said, we'll look at some more different types of three-dimensional figures that are created in class. So go ahead and do your write some key ideas down and do your check your understanding problems.